All right, today we're going to be reviewing for our test. This is just a walkthrough of the completed review sheet. First thing you have to do is turn your calculator on, make sure it's in the right mode. In other words, make sure it's in A plus BI mode. If you want to do question number 1 by hand, here's what you have to do. Whenever you see an I underneath the radical, whenever you see a negative underneath the radical, you take the negative out and it becomes an I. That's where that negative went to. And then you reduce the radical. So 18 is just 9 times 2. 9 is a perfect square. It breaks down to 3. You do the same thing for 72. And because these are like radicals, they can be combined. The second problem, well, you do it the same way, right? Same process, but I'm going to show you another way to attack the problem. Let's try using our calculator. So take the original problem, enter it into your calculator. Second square root negative radical 12, and then hit enter. It produces this answer. And what you want to do is simply find the multiple choice answer that matches it perfectly. Take the one I circled. It happens to be correct. You want to find the one that when you enter it in, does this. See? Same number. Find the multiple choice that matches it perfectly, and that's the correct answer. So now we're question number 3. Question number 3, you have an I to the 16th divided by I to the 3rd. Lots of questions have been asked about this. When do you use the I part in your calculator? You use the I part in your calculator when the number in the exponent is really high. And that's because anything past I to the 7th produces a random answer. So, how much is I to the 16th? Hit the math button, go over to number, go down to I part, hit I to the 16th, and it turns out I to the 16th is 1. Do the same thing for I to the 3rd. It's negative I, and then take that total object and enter it in. You could do it by hand too, but it's just easier in your calculator. And the answer is just I. Okay, same thing for over here. We're just going to take that, we're going to enter it in, hit the math button, go over to number, I part because they're really large powers. So that's I raised to the 27th plus I raised to the 34th. Hit enter. And so here's the answer that you get in your calculator. And is that the same thing as that's written up over there? Yeah, because you can rearrange these and move this to the front so that it becomes negative I minus 1. And that's where they got this from. What do you do for a question like this? Melissa and Joe are playing a game with complex numbers. Melissa had a score of 5 minus 4i, and Joe had a score of 3 plus 2i. What's their total score? You just add them. And you can also add complex numbers in your calculator. 5 plus 4i plus 3 plus 2i. Hit enter and it gives you the answer straight off the bat. You don't have to do any work. Oh, I messed up. I'm sorry. Here's where I messed up. This should have been a minus symbol. 8 minus 2i. In the next question, this is how you do it out by hand, right? You're going to FOIL everything out. I squared is negative 1, and then that'll produce that kind of answer. But if you want to try and do it in an easier way, you can use your calculator and just enter in the original question. Look, it gives you the answer straight off the bat, and you can just choose whichever option matches. What's the conjugate? Okay, what's the product of negative 4 plus 7i and its conjugate? The conjugate of a binomial. Whoops. Oh, no. Let's see if I can get it to match up again. The conjugate of a binomial is the original with just the number in the middle changed. Not the number in the middle, just the sign in the middle changed. Do you see? It's not the complete negative version of the original. Just change that. Okay, so you could do it out by hand. I would rather use my calculator. I'm just going to plug it in because I don't really want to waste too much time on multiple choice. In the short answer questions, you can't use your calculator too much, so you'll have to show all your work there. But let's save some time. Let's just get the right answer and make sure we get all the multiple choices correct. All right, going to keep going. This problem right here, we've got a binomial on the bottom. How do you attack a problem like that? Well, in order to get rid of this in the bottom, you have to multiply top and bottom by the conjugate. You could do that out by hand, or you could use your calculator. Let's see. Let's do the top. 3 is 2 minus 3i, and we're going to type that in. There's the top. Let's do the bottom. It's 2 plus 3i times 2 minus 3i. And that's 13. Final answer. In which quadrant does the sum of these two complex numbers lie? Well, take these two numbers, add them together. That's pretty easy at this point. You get 1 minus 3i. 1 minus 3i. That means that you go plus 1 this way, and you go minus 3i this way. This right here, if you want to think of it, is like the y coordinate. And this right here is like the x coordinate. So just grab them and put them in their correct spot. All right. Do the same thing for this one. What two complex numbers are graphed? They gave you two vectors. Just find out what they actually are in terms of complex numbers. Add them together. And then find the solution listed below. What's the magnitude of a complex number? Anytime you see this word on your test right here, you're going to take out your calculator. Magnitude is the same thing as asking for the absolute value. So hit the math button, go to number, ABS, and type in whatever they gave you. 5 plus 12i. It's 13. That's it. That's all you got to do. Now, sometimes they don't give you such easy numbers to work with, right? So let's take a look. Let's go back over math, number, ABS. We're going to go over to 5 plus 7i. Hit the answer, and it gives you a random number. Go back through the multiple choice answers, plugging them in, and look for an answer that gives that same number, 8.6023 as the answer. Of course, if you wanted to do it out by hand instead of using your calculator, this would be how you do it out by hand, right? It was Pythagorean theorem, but with complex numbers. You had to take the absolute value of the numbers because you can't have a negative distance. And at the end of the day, you'll get the same answer. I'd recommend that you use your calculator, though. Okay, what's the solution set of that equation? Well, you could, once again, if I'm stupid enough or foolish enough to give you an equation and a bunch of answers, you could always just take these answers and plug them into the original equation and find which one works. But we're better than that, and so we're going to solve it algebraically. Subtract 9 from both sides, you get x squared minus 9. Square root both sides, but this is the plus or minus the square root of negative 9, and that reduces down to being plus or minus 3i. What are the roots of this equation? Well, it's asking for the roots. I'm going to use quadratic formula on this. Here's the equation. I'm going to list out A, B, and C and simply plug into it. right? After you get done plugging into it, here you go. And that just reduces, remember the negative pops out in front as an I, and there's your answer right there. It's just choice D. Question 15, everybody's been asking about. Question 15, so how do you, the problem that we're presented with is that you have an x in the denominator. When you have an x in the denominator, how do you get rid of it? You have to multiply by the least common denominator, everything through. So that's what I did, and when you multiply everything through, look what happens. You get this. This takes away the x in the bottom because these two reduce down to being 1. And so then you get that. Just set it equal to 0. Now you're kind of screwed because that's not factorable, but you have all these different ways of trying to solve problems like that now. You could use completing the square, or you could use quadratic formula. Everybody seems to like quadratic formula, so that's what we're going to do. Once again, use the equation, plug in, reduce, solve. 16. 16. Anytime that you're asked about the roots, I mean, I suppose you could just plug this into your calculator and narrow down some answers. Let's take a look at that. Let's just see what would have happened if we plugged this in. 2x squared plus 3x minus 1. Well, they hit the x-axis, so they're definitely not imaginary. There's 2 of them. So they're definitely not equal. Now, finding out whether they're rational or irrational is another story. That really requires either the quadratic formula or using the discriminant. I'm going to use the discriminant because it's the easiest way to get to the answer. If you use the discriminant, you plug in, the discriminant is b squared minus 4ac. You just plug in b, a, and c, and then you get this number, 17. 17 is not a perfect square. Remember, where does the discriminant come from? The discriminant comes from the quadratic formula. The discriminant is this thing underneath the radical. And so if you get a random non-perfect square underneath the radical, you're going to get irrational roots.